Here question number 4. Using cofactor of elements of third column, evaluate delta. The previous one we used to expand through row. Here we are going to expand in column. For this also we had a formula. Delta is equal to sigma I equal to 1 to n Aij into capital Aij. Here I is changing, j is fixed. J is equal to 1, 2, 3 etc. up to n. Here they are expecting third column. They are expecting third column. Third column, how to represent? A13, A23, A33. You write it at the top of the element. Now for that we are going to find a minor. M13. You know, first row and third column should be deleted. So determinant 1 y 1 z, which is equal to z minus y. Next, M23. Second row, third column should be deleted. 1x 1z, which is equal to 1 into z, z minus 1 into x, x. So z minus x. Next, M33, which is equal to, that means third row, third column should be deleted. 1x 1y, 1x 1y, which is equal to y minus x. We found minor. We are going to find out cofactor, that is A13. A13 equal to minus 1 the whole power 1 plus 3 into M13. A13 equal to minus 1 the whole power 1 plus 3 into M13. It is minus 1 the whole power 4. So positive 1 into M13 we found as z minus y. So 1 into z minus y is nothing but z minus y. Next, A23 minus 1 the whole power 2 plus 3. Minus 1 the whole power 2 plus 3 into M23. Minus 1 the whole power 5. So you get it as negative minus 1. M23 is nothing but z minus x. Here using minus 1 and you multiply all the element what it exists inside the bracket. So minus 1 into z minus z minus into minus plus x. It can be written as x minus z. Next, A33 equal to minus 1 the whole power 3 plus 3 M33. Minus 1 the whole power 3 plus 3, that is 6. So you get it as 1. M33 we got it as y minus x, which is equal to y minus x. Already I said that formula. Delta is equal to sigma I equal to 1 to n Aij, capital Aij. Here I said j is fixed as 3, I alone will be changed. That is A13, the arbitrary element as yz. So delta equal to arbitrary element yz, yz into, before that you write delta is equal to A13 into capital A13 plus A23 into capital A23 plus A33 capital A33. You should write the formula and put it inside the box. Again the formula delta equal to A13 capital A13 plus A23 capital A23 plus A33 capital A33. Here A13, the element is YZ. Capital A13 is Z minus Y plus A23, the arbitrary element is ZX. So ZX into X minus Z plus A33, the arbitrary element is XY. The cofactor is Y minus X. Now using YZ, you are going to multiply YZ into Z. So YZ square minus YZ into Y square Z plus ZX square minus Z square X plus XY into Y, XY square minus X square Y. Here I am going to group the terms, that is X square. First, grouping the terms X square Z, X square Y. X square as common, so you should write it as X square. Next, what should be the rest here? Z. Here the rest is minus Y. So Z minus Y. Next term, you are going to take X. You are going to group X terms. Z square X, XY square. X you are going to take it as a common. Then what should be the rest? Y square. Here minus Z square plus. Here you are going to take YZ as common. YZ into. If I am taking YZ as common, here one Z is left over. That should be present here. Here one minus Y is left over. So minus Y. Again I repeat, first I grouped X square term. X square term ZX square into minus X square Y. So X square you should take it out as a common. The rest of the thing you should write it inside the bracket. Plus next I took X as common. Y square minus Z square. Next YZ I took it as common from these two. YZ, so the rest of the thing is Z minus Y. Now X square Z minus Y plus X into here A square minus B square identity. That can be written as A plus B into A minus B. So Y plus Z into Y minus Z plus YZ into Z minus Y. Here in the step you have to see which are the things are common. Here you have Z minus Y. Here also you have Z minus Y. But here alone Y minus Z. That we can take it as Z minus Y. How it will change you see. Which is equal to Z minus Y as common you are going to take. Then inside the bracket X square. Here I took Z minus Y as common. So the plus it becomes negative. Minus X into Y plus Z plus YZ. Next Z minus Y into X square minus XY minus XZ plus YZ, which is equal to, here you have to take Z minus Y, you have to group these two. So you have to take X as common, inside the bracket X minus Y. Here you have to take Z as common, Y minus X. Minus XZ, YZ. Now, in both the things which is common, z minus y already we had. Here you see x minus y. Here you had y minus x. You should consider as x minus as common. Then the term how it going to change, x minus y, x. Here it will act as, the positive will act as negative. Now, x minus y, the term should come under the cycle. So, x minus y, after that what it should be, y minus z. So, minus 1 you should take it as common, minus 1 into y minus z. Next, how I want z minus x. Here also the same, I am going to take minus as common, then I am going to write it as z minus x. If you want, you should check whatever thing if you want to write, that should not be disturb the previous. Modification you can do, but it should not disturb the previous. Minus 1 into z, minus 1 into minus plus x. So, I didn't disturb the previous, but I wrote in my convenient way. Finally, I arrived the result as minus 1 into minus 1 plus. So, x minus 1 into y minus z into z minus x. Again I repeat, yz, that is A13 plus A23 capital A23 plus A33 capital A33. A13, the element, arbitrary element is yz into z minus y plus the next 2, 3, the arbitrary element is zx. So, zx into x minus z plus xy into y minus x. Simple multiplication I did. Yz square minus y square z plus zx square minus z square x plus xy square minus x square y. Now, here I did the grouping the terms zx square and minus x square. In this, x square is common, so I wrote x square into z minus y. Next, x term I collected, minus z square x plus xy square. So, x I took it as common, inside the bracket I wrote y square minus z square plus yz as common, z minus y. X square into z minus y plus, here I apply the identity, that is a square minus b square, that can be written as a plus b into a minus b. So, I wrote y plus z into y minus z plus yz into z minus y. Finally, in all the three I took z minus y as common. So, how this expansion is going to change, you see, x square, here I took z minus y as common, so the positive will act as negative, x into y plus z plus yz. Now, next step, I multiplied x square minus xy minus into plus minus, so minus xz plus yz. In these two I took x as common, here I took z as common. So, x into x minus y plus z into y minus x. In both the things, x minus y I am going to take it as a common. For that purpose, the plus it will act as negative x minus z. Now, I need, it should be in the cyclic form. So, x minus y, after that I need y minus z. So, for that purpose I took minus as common, minus 1 into y minus z. Here also the same, I said cycle. So, y after z, z after x. So, here x minus 1, minus 1 into z minus x. Finally, minus 1 into minus 1 plus. So, everything it comes under a product, x minus y, y minus z, z minus x. Cycle I said y, it end, here it start, here z is ending, here it start, z minus x. Delta is equal to, final answer, delta is equal to x minus y, y minus z, z minus x.